In this class, we'll be solving this problem under the derivative of vector. And the question says, if vector A is equals to, open bracket, 2u squared minus 4u, close the bracket, all into I, plus 2 cos uj minus 5 sin uk. Find the derivative of vector A with respect to u, that is the A, the u, and the second derivative as well of vector A with respect to u. What this to me is that this one will differentiate it once, while this one will differentiate it twice. So let's begin with our solution. We're told that vector A is equals to this. Let me write it out. Vector A equals to 2u squared minus 4u, close bracket, I, plus 2 cos uj, this is I, this is j, this is k, minus 5 sin uk. Okay, so the first one says the derivative of A with respect to u. If you see that this A with respect to u, that is the value of this A depend on the value of this u. So this is just like the general method of differentiation. You can watch my video on general method of differentiation, but notwithstanding, I will still explain it here. I will explain it here. So let me solve this one first. The A, that is the derivative of vector A with respect to the u, equals to, what this simply means, since I'm differentiating with rest A, this is A here with respect to u, so I will focus on u here. What happens if I'm using the general method? I will use the power of u to multiply it. I will now subtract 1 from the power. The same thing applicable to this, but this one is different. This and this is different. Don't worry, when I get there, you understand it better. So let's proceed. For this, if I'm to differentiate this, I will use this power to multiply this, then subtract 1 from the power, as I've said earlier. So it will be 2. You know, 2 is already here before. So if I multiply with this 2, it will be 2 times 2. Then, as I've said, I will subtract 1 from the power of that what? This u, which will become 2. This will become 2 minus 1. Okay? So, mind you, this u here has a power of 1, right? If I use 1 to multiply this 4, it will still give me what? 4. Let me write this minus 4. But if I now subtract 1 from that power, you know this u has a power of 1 before. So if I subtract 1 from it, it will become 1 minus 1. I hope we are following. Okay, but mind you that everything here, they are all into what? I. So I will do it like this. I plus, but before I write this, you know, if I differentiate this u, this value of cos here depend on this u. That is why I didn't I don't need to say I will use the power to multiply. No, whenever you differentiate cos u, it is not only cos u. You know, in our differentiation we said when you differentiate cos x, it will give you what? Minus sin x. It's standard that whenever you differentiate cos x give you minus sin x. What if it is cos u? What will it give me? It will now give me minus what? Sin u. So if I differentiate this, it will give me minus sin u, right? And mind you that 2 is already here before, right? So it will just be like, you know, let me write this plus first. This plus, right? I hope we are following. I will write this 2. Like now this 2 is there before already. So if this one change to minus sin u times 2, that is times 2, this 2 will multiply it to give you minus 2 sin u, right? So this place this place will become no longer plus, but it will become what? Minus. It will become what? Minus, not plus. It will become minus 2 sin u into what? Into j. Minus, here is minus 5, right? If you differentiate sin u, it will give you cos u, not minus. But whenever you are differentiating from cos to minus, it will give you whenever you are differentiating from cos, at least it will give you minus sign. But whenever you are differentiating from sine, it will give you just ordinary cos. So this will give you 5 cos, mind you, minus is already there before. 5 cos u, k is there, Okay. So this will give us the derivative of a with respect to the u equals to, now these 2 times 2 will give me what? 4. U 2 minus 1 will give me 1, right? It's the same thing as u raised to the power of 1, that is u minus, now okay, minus this is u raised to the power of 1 minus 1, right? 1 minus 1 will give me what? 0, right? So this will become u raised to the power of 0. Any number raised to the power of 0 or any variable raised to the power of 0 will give me what? 1. So this u raised to the power of 0 will give me 1. If I use the 1 to multiply this for, what will it give me? It will give me what? 4. So this will be 4. Mind you that everything, they are all into what? I. Yeah. So this will be I. Already we have solved this. It will be minus 2 sine uj minus 5 cos uk. So that is our final answer for this, for the first derivative, which is equals to what? That is the final answer. Why for this second? As I've said, we differentiate it once here, so you will not differentiate this again. When you differentiate you differentiate this once. When you differentiate it once, it gives you. Why this one simply means you differentiate it twice. So to get this, it will be the second derivative. We have differentiated it once here, right? So I will not differentiate it again with respect to u. That is a with respect to u. So I will use the power, as I've said, to multiply it, subtract 1 from the power. So the power here is like 1, right? If I use 1 to multiply 4, it will still give me what? 4. Mind you, the power here already is 1, right? So I will subtract 1 from the power. From 1, I will subtract 1, you give me this. But this one is just ordinary number. Do you see u here? No. And we are differentiating a with respect to what? U. So this will change to 0. Since there's no u here, it's changed to 0. So this becomes 0. This becomes 0. I can decide to leave it, and I can decide to write it like this. All into brackets I. So now I have minus 2 here before, right? If I'm differentiating sine u, what will it give me? Sine u, I said it will give us what? Cos u. So this will just change to cos uj. Here I have a minus 5 already, right? Let's assume I write the minus 5. So if I differentiate this cos u, cos u, if I'm differentiating it to give me minus sine u, right? So mind you that 5 is already here, so this will change to minus sine u. Minus sine u. Mind you, k is also there. K is also there. Let me just put the k here. Yes. So this will give me 4 u raised to the power of 1 minus 1. It will give you u raised to the power of 0, and u raised to the power of 0 will give you 1. 1 times 4 will still give you 4. So this is 0. Let me leave that. So it will be 4i minus 2 cos uj. But this place, this is minus 5. If you use to multiply this, minus times minus will give me what? Plus 5. So I will now left it plus 5 sine u k. So that is our final answer to that. Do well to subscribe. Consider to share to your friends, like, comment, and share. Thank you.